Let's take a look at some of these examples of these three concepts. So the first thing you want to do is get in the habit of labeling your axes. By labeling your axes, it'll help you graph things accurately. It'll also help you understand how trigonometry works in the long run. So labeling those is very important. Of course, this is 360. And so the first one, 13, just is in quadrant 1. Now, you don't need to get out a protractor or something. Just estimate where that is. The key is labeling the positive rotation at 13 degrees. That's the key to making sure we understand how to do that problem. And so the next big step is to find a coterminal angle, both positive and negative. And all you do there is you add 360 or you subtract 360. Now, visualizing this is pretty easy, right? So coterminal would be to go back around and stop here. Now, to do that algebraically, you would take 13 and add to 360, which would be 373 degrees, but you would want to label that on this as well. It needs to be labeled. To do the negative rotational angle, visually is pretty easy. We're going in the negative clockwise direction. And so that would be, to take 13 and subtract 360 or get negative 347 degrees. So not so bad. But what we're going to do is we're going to make sure we label it. We're going to make sure we have our negatives when we're going in the negative direction and all of those important things. So then we get to the reference angle, which for some reason students have trouble remembering. In quadrant 1, okay, the reference angle is to 0, so the reference angle in quadrant 1 is itself. If it's in quadrant 2 or 3, you reference to 180. If it's in quadrant 4, you're going to reference to 360. So let's take a look at 102. So if I had 0 degrees here, this is 90, this is 180, this is 270, then 102 is going to be approximately here, and I'm going to show that positive rotation, and I'm going to label it 102. Now I'm going to add 360 to this, and then I'm going to subtract 360 to this to show the negative and positive coterminal angles. Now, you could do it more than once. I mean, if you wanted to add 360 twice, that would also be coterminal. You just have to draw a separate picture for that. So the first one, 102 plus 360 is, of course, 462 degrees. And to subtract 102 minus 360 would be negative 258 degrees. So to show a picture of that, again, the visual is easier than the actual math. So the visual of the positive coterminal is that, 462 degrees. And the visual of the negative rotational angle, coterminal angle is to go to there. You can see clearly that's not 360, so that's why it makes sense that it's negative 258. Now to find the reference angle, again, we're referencing to the closest x-axis. So we're not going to reference back here. The closest x-axis is now 180. And 180 minus 102 is 78. Or a better way to say this is, how far away is 102 degrees to get to 180? Because reference is always distance, so it can't be negative. So maybe don't think about subtraction, maybe think about how far away it is. Maybe that makes more sense. So then we come to something like 560, which would be more than one time around. So the question is, where in the world do you graph it? Well, let's start by labeling our axis. And then once we label our axis, let's try to figure out where it is by using coterminal angles. So for instance, if I take this number and I subtract 360, I can see that it's terminating actually at 200 degrees. I just won't label it 200, right? So 200 is below 180, it's right about here. And that may be more than you need, but just make it easy to draw and label it. Just don't do this, because that's 200 degrees. You want to show that the original angle actually went around once and is 560 degrees. So from here, I can easily visualize what these are. So my negative coterminal angle would be to go to here. And it's kind of interesting because there are more than one, right? So the one that you're looking at there is going to be negative 160. And you can see that it's not very far this way. It's clearly not even to 180. And I got that by taking 200 and subtracting from 360. But if I did it the original angle, right? If I did the original angle, this 200 is actually the positive coterminal angle, right? Because 200 would be here. So it's kind of interesting. It's almost like it's backwards from the original problems we did. But I think drawing the visual helps you understand which one is which. So I don't know. I would recommend understanding the algebra, but also drawing the picture first. And of course, you could go around again and again and again. So what I mean by that is 560, if I added 360 to it, that would be 920. And I could write 920 down here as one of my other coterminal angles. It would be what's known as a second coterminal angle because you're going beyond it. And it would look like this, right? You'd go around, you'd go around, and then you'd go around again. And that would be 920. So just keep in mind, there's more than one. I always try to find the easiest, most reduced version or the one that's closest to the original, but you don't have to. All right, so what's the reference angle? The reference angle is to, again, it's distance. So how far away is 200 degrees from 180? It's 20 degrees away. Now, this can be extremely tricky if you've not found your coterminal angle, and I ask you how far away is it from 560. So some student might say 560 minus 180 is 380 degrees. And you can see the problem there. A reference angle is always acute. If you go back to the definition, the reference angle are always acute angles. So you can't say that it's 380 degrees. You have to reference it from a first quadrant terminal angle of whatever you're given, meaning something between 0 and 360 and then reference to the x-axis. It's going to be, these angles are always acute for reference angles, and they're always positive. All right, let's look at some negative rotations. All right, so this is no big deal as long as you're labeling your axis. So if I label it this way and say this is negative 90, this is negative 180, and this is negative 270, this problem is not difficult. It just requires you to, label axes. And so negative 75 would be right about here. And so I'm going to label that as negative 75. And then to do a coterminal from this, I'm going to take negative 75, I'm going to add 360, and that'll come out to 285. I'm going to take negative 75, I'm going to subtract 360, that'll be negative 435. So let's write this down and see if, sometimes you can write them down without having to draw them. Sometimes finding them helps, and then drawing them sometimes gives you some more information. But on this very first problem, I think it was just good to, again, take negative 75, subtract 360, and get, negative 75 plus 360 and get 285, and negative 75 and subtract 360 and get negative 435. Let's draw those. So to draw the positive coterminal angle, that would actually be going in this direction. Notice it's not 360 degrees, and it's going counterclockwise or positive. And then to do the negative one, we're going to go in the same direction as the original. And when we do that, we're going to show it coming all the way back around, and that clearly is larger than 360, making the answer maybe make a little more sense. So how do I do reference in the fourth quadrant? Because notice this is in quadrant 4. So to do reference in the fourth quadrant, you're going to reference to 360. So this is kind of interesting because negative in the negative direction, if it's in quadrant 4, you just change the sign from negative to positive. However, if I was looking at 285, I would need to take 285 and subtract 360 minus that to find out that it was 75. And that's why the whole coterminal thing is so important. Sometimes the coterminal angles help you figure out the reference angles. All right, so negative 185, again, if we label 0, negative 90, negative 180, negative 270, then what happens is negative 185 would be just a sliver above 180 negative, so negative 185 would be there. And then what I do from there is, again, I add 360. So if I add 360, I get its positive coterminal angle, which would be slightly, you could have done that one, you could have done that one just using some algebra tricks. It's just 175 is what I was trying to say. So 175 and 185 make 360. So you can show that one really easily that that's 175. And then you would take negative 185 and subtract 360 to get the negative coterminal, which would be negative 545. And you would show that one, of course, as we've talked about many times at this point, by going all the way around and going back to that coterminal angle. So in this case, the reference angle would be 5 degrees because we're referencing quadrant 2 to 180. This is 175 or negative 185. However you look at that, the distance to the x-axis is 5 degrees. All right, so now we get to negative 1,000, which I want you to think about this in terms of like watching ice skating in the Olympics or something, or watching the X Games and watching a professional skateboarder do a multiple spin. And if they spun around 3 times, they'd be doing a 1080. And you might have heard that, especially the X Games, a 1080. Well, the way you figure that out, you actually need to get back to a reference angle that will actually be on, a normal axis, right? So if you take negative 1000 and you add 360 to it, you're at negative 640. So you have to do it again, right? And then you get, if I add another 365, then I'm going to be at negative 280. Now, why is that important? As long as this number is less than 360, you can then graph it, right? Because if I label my axis, which is the key to understanding how to graph these, the number of people I've had that have had trouble with this, when I say, did you label the axes? And they say no, and that's the root of the problem. So negative 280 is going to be here, right, going in this direction. But I have to show the original problem. So you can see that it looped around twice. So when I show this original problem, I'm going to start here, go counter. So that is 280, then the other 365, then the other 365, and then I stop and I label that negative 1000. And I want you to think about that again as watching somebody spin around on like a skateboard or a professional, an ice skater. So I currently right now can see one of my coterminals, right? So if I were to go in the negative direction and stop here at negative 280, that can be my coterminal in the negative direction. And then there's also another one I could have labeled. Like if I just went one of those, I would have negative 640. And then to get my positive, you can see right here, it's a very acute angle. And so that one would be, what is negative 280? If I were to add 360 back to that, I could easily call that 80 degrees. And that again is my reference angle, right? If I'm referencing quadrant 1, I'm asking how far away is it from 0, which is 80. So I think once you do these problems, I think you'll understand why this is taught all at the same time. So a quick review of what we did was we talked about positive rotations and negative rotations. We did positive coterminals and negative coterminals. And sometimes by finding these positive and negative coterminals, we actually discover what the reference is. The reference is the distance from the x-axis, which in quadrant 1 is the actual angle. In quadrant 2 and 3, we reference to 180, and in quadrant 4, we reference to 360. So I would definitely figure out these coterminals before you think about the reference angle, because sometimes it helps you understand what it is.